My name is Banu. Today I am going to explain about the topic of classification and operation of sequential circuits and flip-flops in switching theory and logic design. Let us go into our topic. Classification and operation of sequential circuits and flip-flops. Explore the fundamental building blocks of digital memory and sequential logic system that powers modern computing. Yeah, as we know that switching theory and logic design is a part of uh, designing digital designing. So I have chosen the topic of sequential circuit flip-flops and classification and operation of sequential circuits. No. Sequential circuits are two types. They are synchronous and asynchronous. When we come to synchronous circuits, state changes only on clock edges in synchronous circuits, and synchronous circuits uses flip-flops as memory, and synchronous circuits predictable time and control, whereas asynchronous circuits state changes immediately upon time, uses latches without clocks, faster response but harder to design. When compared to synchronous circuits, asynchronous circuits are hard to design. And in synchronous circuit, the state changes on clock edges. Synchronous circuits uses flip-flops like SR, JK, T, and D flip-flops that we are going to discuss further. And as we know, synchronous circuits takes less time and have more control, whereas asynchronous circuits state changes immediately upon time. When time changes, the state of the circuit also changes. Asynchronous circuit uses latches without having clocks. Asynchronous circuits have faster response, but they are a bit harder to design. When we come to sequential circuits possess memory, their output depends on both current inputs and past states, enabling complex behavior and state machines. As we know, sequential circuits depends on both present and past inputs, enabling their behavior. And next, NAND and NOR latches, basic memory elements. NAND latch are NAND latch and NOR latch. NAND latch consists of cross-coupled NAND gates, whereas NOR latch consists of cross-coupled NOR gates. NAND latch consists of active low inputs like S, comma R, S bar, comma R bar, whereas NOR consists of active high inputs like S, comma R. NAND latch have bistable output storage, whereas NOR latch maintains stable states. These latches are used in designing of asynchronous circuits as we have discussed here. So there are two types of latches mainly. They are NAND latch and NOR latch. Uh, as we can see, NAND latch are used for cross-coupled NAND gates and NOR latch used for cross-coupled NOR gates. NAND latch have active low inputs, whereas NOR latch have active high inputs. NAND latch maintains bistable outputs S bar and R bar, whereas NOR latch maintains stable outputs S, comma R. Next, flip-flop edge triggering storage elements. Flip-flops are edge triggering storage elements. Clock control output changes on clock edges, rising or falling, providing synchronization. Yeah, next we are going to flip-flops, and there we use the clock control. We represented the clock control as CLK. Here we can check whether the clock is rising or falling. Next, we have four main types of flip-flops. They are RS, JK, D and T flip-flops, offer different input configurations and behavior. Further, we are going to see them. Asynchronous overrides, preset set clear inputs override normal operation for initialization. Yeah, in asynchronous, as in excitation table, and in that table we are going to use this preset set clear reset and etc options. Building blocks, flip-flops form the foundation of all synchronous sequential circuits and state machines. Yeah, these flip-flops are basic building blocks of the sequential circuits. By using these flip-flops, four types of flip-flop, we can design the sequential circuits. Now, let us go into the flip-flops. First, SR flip-flop, operation and tables. The SR flip-flop is reset and set flip-flop. It is also known as reset and set flip-flop. Is the fundamental building block with the set, reset, and clock inputs plus asynchronous preset. Yeah, we can see the circuit diagram. This is the diagram of SR flip-flop. And let us come into the characteristic table or truth characteristic truth table. Here, when the input S and R are low, means 0 and 0, and the clock is rising, Q is equals to Q, no change in hold. Whereas S is 0 and R is 1, clock is rising, Q is equals to 0, which is reset state. And where S is equals to 1 and R equals to 0, clock is rising and Q is 1, which is set state. Whereas S is 1 and R is 1 and clock is rising, means this is high conditions. S is high and R is high, clock is also rising. Then the Q is said to be invalid conditions, which is forbidden state. Now let us come to the excitation table. Q is current and Q is next. S and R are the outputs. Then uh, Q is 0 and Q current is 0 and Q next is 0. Then S is equals to 0 and R is also equals to 0. If Q current is equals to 0 and Q next is equals to 1, then S is equals to 1 and R is equals to 0. If Q current is equals to 1 and Q next is equals to 0, then S is equals to 0 and R is equals to 1. If both Q current and Q next is equals to 1, then both S and R are going to be 0 and 0 respectively. Now, these are the excitation table and characteristic table of SR and SR flip-flop. Now, let us go into the circuit diagram. Here, R and S are the both inputs of the AND gate. These AND gates are connected to the OR gates, OR gates with a bubble, so it is XOR gate. And these XOR gates outputs are connected to the opposite of XOR gates. We can see that third XOR gate output is connected to fourth gate input, and similarly fourth gate output is connected to the third gate input. And these first two AND gates outputs are connected to the XOR gates inputs. The resultant XOR gates gives Q and Q bar, which are going to be complement. If Q is equals to 1, then Q bar is going to be 0, and if Q is equals to 0 and Q bar is going to be 1. Here we have chosen the clock as rising for every condition, and R and S are those inputs are going to be taken by us as shown in the characteristic table and excitation table. Next, let us come to JK flip-flop operation and tables. The JK flip-flop resolves the invalid state of RS flip-flop by implementing the toggle function. When both inputs are 1, it is toggle. Here in SR flip-flop, we have checked that when S and R are going to be 1 and clock is rising, here there the state is invalid. So we use JK flip-flop for this state to be as followed, and to implement that state. So that state is here named as toggle state. Now let us go into the characteristic table. When J is equals to 0 and K is equals to 0, clock is rising. Q next is Q, so it is hold state. When J is equals to 0 and K is equals to 1, clock is rising. Q next is equals to 0, so it is reset state as similar to there. J is equals to 1 and K is equals to 0, clock is rising. Q next is equals to 1, which is set state. When J is equals to 1 and K is equals to 1, clock is rising. Q is equals to Q bar, which is toggle state. Here to satisfy this toggle state in SR flip flop, it is invalid. So to satisfy this, we use this JK flip flop. Now, Q current and Q next excitation table. Q current, Q next, J and K. When Q current is equals to 0 and Q next is equals to 0, J is equals to 0 and K is equals to X. When Q current is 0 and Q next is 1, J is going to be 1 and K is going to be invalid. Like X is nothing but invalid case. So Q current is 1 and Q next is equals to 0. Then J is going to be invalid and K is going to be 1. When Q current is 1 and Q next is 1, then J is going to be invalid and K is going to be 0. Here we can see that when either one input is, when both are 0 or 0 1, J is going to be as 0 and 1. Similarly in K, when 1 and 0 1 1, here K is going to be 1 and 0. Remaining cases both are going to be like invalid, which are we can observe here in excitation table. Now let us go into the circuit diagram. Here we can see the NAND gate J is, first NAND gate J is connected to the second NAND gate. Like if we consider as 1, 2 and 3, 4 as similarly in SR flip flop, then first NAND gate have consist of one J input and clock pulse, and other as Q bar as the input for the first NAND gate, and for the second NAND gate one input is K and another input is clock pulse, and we consider another input as Q if it for the second NAND gate. Similarly, the first NAND gate output is connected to the third NAND gate input, and the second NAND gate output is connected to the fourth NAND gate input. Again, this fourth and third NAND gate outputs are connected, crossly connected as inputs. Resultant we get as Q and Q bar, which are going to be complement. If Q is equals to 0, then Q bar is going to be 1, and Q is equals to 1 and Q bar is going to be 0. So by this, as we told that clock always is going to be rising condition. Next, uh, T flip flop operation and table. T is that T flip flop is derived, T flip flop or toggle flip flop is derived from the JK flip flop by connecting J and K to a single T input. When T is equals to 1, the toggle characteristic table. When T is equals to 1, toggle. When T is equals to 0, clock is uprising, Q next is equals to Q, and description it is hold state. When Q is equals to, when T is equals to 1 and clock is rising, Q next is equals to Q next is Q bar, which is toggle state. Here T flip flop is derived from JK flip flop. Here J and K are both are connected to a single input T, where T is equals to 1, we consider as T is equals to 1. So this consists of T is nothing but toggle flip flop, it is also called as. So when T is equals to 0 and clock is rising, Q is equals to Q, and which is, this is hold state. And when T is equals to 1 and clock is uprising, then Q next is equals to Q bar complement, which is toggle state. Excitation table, Q current and Q next is equals to 0, both Q current and Q next is equals to 0, then T is also equals to 0. When Q current is equals to 0 and Q next is equals to 1, then T is going to be 1. When Q current is 1 and Q next is equals to 0, T is 1. When Q current is 1 and Q next is 1, then T is going to be 0. Now here we can see that this is as similar as your JK flip flop. Let us consider these both NAND gates are 1 and 2, and next the other two XOR gates are as 3 and 4 gates. Then the first NAND gate input consists of T flip flop, and other as clock pulse, and other input as Q, and the second NAND gate consists second AND gate consists of sorry AND gate consists of one input T and another input clock pulse and another input as Q bar. These both AND gates outputs are directly connected to the inputs of 3 and 4 XOR gates. Uh, Next, again their XOR gates outputs are connected in like third gate output is connected to fourth gate input, and fourth gate output is connected to third gate input, and they both are resulting to Q and Q bar, which should be complement to each other if Q is equals to 0 and Q bar equals to 1, as we have talked in previous also. So similarly, this is the diagram. Next, D flip flop. The D flip flop is nothing but data flip flop, is the simplest and most widely used flip flop. It captures the input data D and transfers to the output Q on the clock edge, completely eliminating invalid states. Here, D flip flop is most commonly used by us, which is data flip flop. Um, D flip flop is the simplest and most widely used flip flops. It captures the input data D and transfers to the output Q on the clock edge, completely eliminating invalid states. It eliminates invalid states and process and sends the output D and transfers the output D, like um, when D is equals to 0, clock is uprising, Q next is equals to 0 and it is reset state. When D is equals to 1, clock is uprising, Q next is equals to 1 and it is set state. Excitation table. If Q current is equals to 0 and Q next is equals to 0, then D is going to be also 0. If Q current is equals to 0 and Q next is equals to 1, then D is going to be 1. If Q current is equals to 1 and Q next is equals to 0, then D is going to be 0. If Q current is equals to 1 and Q next is equals to 1, then D is also going to be 1. Now, let us check about the table. Here, the D input is connected to first NAND gate, and the complement of D is connected to the second NAND gate input, and clock is given to as input for both first and second NAND gates. The first NAND gate output is connected directly to the third NAND gate input, and the second NAND gate output is connected to the fourth NAND gate output. Here, third and fourth NAND gate outputs are uh, complement like connected in reverse. Third NAND gate output is connected to fourth NAND gate input, and fourth NAND gate output is connected to third NAND gate input, and both are resulting in outputs Q and Q bar, which are complement to each other. Now, reset and clear terminals in flip flop. The set, reset, and states we have talked till now. Preset set asynchronously forces Q is equals to 1 independent of clock signal, overrides or normal operations for immediate state initialization. Here, here preset is um, all used to perform all normal operations immediately, and clear or reset asynchronously forces Q is equals to 0 independent of clock signal, essential for system startup and reliable initialization protocols. Here, clear state is used to um, is used to reset, restart the process with respective of the signals, like with respective of the forces. We use it to reset the protocol, reset the initialize the system. Active level can be active low standards or active high standards, depending on circuit design. Usually active low is to prevent accidental any activation. Active high or active low is used to uh, check the standards. Generally we use active low for our circuit design. Critical application used to initialize or override flip-flop state in complex sequential circuits, ensuring predictable startup behavior. Like critical application is used to override like flip-flop states, one flip-flop on another flip-flop states. To overcome this, we use critical application. Summary and key takeaways: classification of sequential circuits, synchronous and asynchronous. We have talked about that. And memory elements, NAND, NOR latches, like different types of latches, like different. And next we have talked about different types of flip flops like RS, JKT, and D flip flops, their behavior and their and their circuit diagram too. Design tools: truth, excitation table, guide systematic design and analysis of sequential circuits. Control inputs, we have next talked about control inputs. Present set provides synchronous realizable initializations. Next, master essential deep understanding of these concept, fundamentals to design robust and reliable digital systems. So that's all. Thank you.